October 24th, 1944. The waters surrounding Seymour Island were still, bathed in the eerie silence of a starless night. The Philippine Sea appeared serene, almost unaware of the devastating clash about to unfold. Moments after midnight, radar operators aboard the USS Iowa picked up faint signals to the west, fast-moving targets emerging from the darkness. These were Japanese heavy cruisers, part of Admiral Kurita's center force, retreating after the chaotic battle near Samar. For those aboard the Iowa, this was the moment they had prepared for. Inside the plotting room, engineers bent over mechanical fire control computers, massive analog machines working tirelessly, feeding data from radar, wind sensors and rangefinders. A red light flashed on the Mark 8 radar display, the range confirming a target 35 kilometers away. The bearing indicated it was likely the cruiser Kumano, moving north at 25 knots. Captain John McCrea gave the order that would resonate across the Pacific. All batteries, stand by for full salvo. The men in Turret 1 braced themselves. Each of the 9 16-inch Mark 7 guns weighed as much as a locomotive, with shells weighing 2,700 pounds apiece. With military precision, the shells were loaded. When the firing key was engaged, a shockwave reverberated through 57,000 tons of steel. The night erupted in an orange blaze. The concussion flattened the sea near the bow. Observers on nearby ships felt the force, as if the ocean had been struck by a giant blow. 40 seconds later, the horizon blazed. Spotters, binoculars raised, saw the flash, followed by another explosion, and then a column of flames reaching skyward. The first shell had found its target. One officer whispered, "Good God, we hit her." Yet there was no celebration, only the hum of machinery resetting the guns. Within minutes, 5 more shells followed, each guided by radar corrections, finding their mark in the darkness. On the Kumano, chaos erupted. Officers stared in disbelief as explosions tore through the cruiser's aft section. They hadn't heard aircraft or seen incoming torpedoes. The sky was still. Then the thunder arrived, delayed by the vast expanse of the ocean. The gunnery officer exclaimed, "Impossible. No ship could fire from this distance." But 6 American shells had crossed 21 miles of open water and found their target with pinpoint precision. In those few minutes, the myth of invincibility surrounding Japan's naval forces began to disintegrate. What their admirals didn't know was that this wasn't a stroke of luck. It was the inevitable result of mathematics, radar, and industrial precision converging on the high seas. The Iowa's fire control system didn't guess. It calculated. It measured everything from humidity to wind, even accounting for the Earth's curvature. Each shell was engineered to hit its target. When the echoes faded, the Pacific returned to its eerie silence. But nothing was the same. Aboard the Iowa, the deck still vibrated. The gunners wiped soot and sweat from their faces, their ears ringing from the blast. Somewhere beyond the horizon, a Japanese cruiser burned, its crew stunned to have been struck by an unseen enemy. The night the sea trembled was more than just a battle. It was a revelation. America had transformed physics into a weapon, and distance no longer provided safety. The Iowa-class battleships were conceived long before that fateful night in 1938. As war clouds gathered over the Pacific, American engineers were already designing something radical, battleships that could keep pace with aircraft carriers and strike faster, farther, and harder than anything afloat. The result was not merely another warship. It was a machine designed to turn physics into strategy. Each Iowa-class ship was a floating city of steel and electricity, stretching 887 feet in length and displacing nearly 58,000 tons at full load. Equipped with 9 16-inch Mark 7 guns, the most advanced naval artillery ever built, each could launch a shell weighing as much as a small car over 23 miles with pinpoint accuracy, guided by a fire-control computer system that turned raw data into destruction. At the core of the ship were Mark 8 and Mark 13 radar rangefinders, rotating eyes that could pierce rain, smoke, and darkness. Unlike older ships that relied on human eyesight, the Iowa could see through the chaos of war. The concept was simple. Let the machines think faster than the men. Inside the plotting room, analog computers constantly calculated range, wind drift, shell flight time, and even the curvature of the Earth. By the time Japanese gunners raised their binoculars, the Iowa had already calculated where they would be 30 seconds later. While Japan's shipbuilders revered armor and tradition, American engineers pursued something different: precision. The Yamato, Japan's pride, was larger and more heavily armored, with 18-inch guns and thicker plating than any other vessel ever built. But it lacked one critical feature. The Iowa was a masterpiece of integration. It was a symphony of sensors, servos, and gyros, all communicating through mathematics. The Iowa's weapons didn't just fire, they computed. In 1944, this distinction was no longer theoretical. The war had evolved from a contest of courage to a test of calculation. Japan's admirals still believed victory was determined by spirit, the Bushido Code, the Emperor's will, and the bravery of men. But American admirals relied on something colder, far more relentless: industrial logic. They didn't build ships for honor. They built them for results. By the time the Iowa reached the Pacific, its power plant, driven by 4 General Electric turbines, could produce 212,000 horsepower, enough to propel the ship through the waters at a speed unmatched by most enemy vessels. The USS Iowa cut through the calm Philippine Sea, its radar operators detecting faint, fast-moving contacts just after midnight. The targets were Japanese heavy cruisers, remnants of Admiral Kurita's center force retreating from the chaotic battle off Samar. Aboard the Iowa, it was a moment they'd been waiting for. In the ship's plotting room, engineers worked with mechanical fire control systems, analog machines feeding data from radar, wind sensors, and rangefinders. A red light flashed on the Mark 8 radar, confirming a target 35 kilometers away, likely the Kumano, moving north at 25 knots. Captain John McCrea gave the order, "All batteries, stand by for full salvo." The men in Turret 1 braced themselves. The 9 16-inch Mark 7 guns, each weighing as much as a locomotive, were loaded with shells weighing 2,700 pounds apiece. With precision, the shells were loaded into the guns. The firing key was pressed, and the ship shuddered under the shockwave. The night exploded in a burst of orange light. The concussion hit the sea around the Iowa's bow. Nearby ships felt it, as if the ocean itself had been struck. 40 seconds later, the horizon lit up. The first shell hit its target, followed by another and then several more. The Kumano's officers, stunned, watched as their cruiser erupted. No aircraft had been spotted, no torpedoes in sight. The sky was still. The thunder that followed, delayed by the vast sea, was unlike anything they had experienced. The gunnery officer in disbelief exclaimed, "Impossible!" No ship could fire accurately from that distance, yet 6 American shells had crossed 21 miles of open sea with pinpoint precision. The myth of Japan's naval invincibility began to unravel. This wasn't luck, it was the result of mathematics, radar, and industrial perfection. The Iowa's fire control system didn't guess, it calculated. It measured everything from wind to the curvature of the Earth. Each shell was engineered for impact. As the echoes of the battle faded, the Pacific returned to its silence, but nothing remained the same. Aboard the Iowa, the deck still trembled, the gunners wiping sweat and soot from their faces. Somewhere beyond the horizon, a Japanese cruiser burned, its crew stunned by an unseen enemy. That night, America's mastery of physics had turned distance into vulnerability. The Iowa-class battleships were conceived long before that night in 1938. With war clouds looming over the Pacific, American engineers designed a ship that could keep pace with aircraft carriers and strike faster and farther than any vessel before. The result was not just a battleship, it was a weapon built to turn physics into strategy. At 887 feet long, displacing nearly 58,000 tons, the Iowa was both elegant and terrifying. equipped with 9 16-inch Mark 7 guns, the most advanced naval artillery ever built. It could launch shells over 23 miles with pinpoint accuracy, guided by fire control systems that transform raw data into destruction. At the heart of the ship were the Mark 8 and Mark 13 radar rangefinders, eyes that could see through rain, smoke, and darkness. Unlike older ships that depended on human eyesight, the Iowa could pierce the chaos of battle. The concept was simple: let the machines think faster than the men. Inside the plotting room, analog computers constantly calculated everything from range to shell flight time. By the time Japanese gunners raised their binoculars, the Iowa had already calculated their position 30 seconds later. While Japan's shipbuilders prized armor and tradition, American engineers pursued precision. The Yamato, Japan's pride, was larger, with 18-inch guns and thicker armor than any ship before. But it lacked the Iowa's integration. The Iowa was a symphony of sensors, servos, and gyros, each component speaking the language of mathematics. The Iowa's weapons didn't merely fire, they calculated. In 1944, this distinction was no longer theoretical. The war had evolved from a test of courage to one of calculation. While Japan's admirals still believed in spirit and bravery, America's admirals relied on industrial logic. The Iowa was built for one purpose: results. Powered by 4 General Electric turbines, the Iowa's plant could produce 212,000 horsepower, propelling her faster than most destroyers. She was a combination of armor and agility, the embodiment of a nation that viewed technology as destiny. The Iowa could reach 33 knots while firing broadsides that displaced the ocean around her. Within her machinery decks, boilers glowed with the heat of a steel mill, converting crude oil into power with industrial efficiency. Each shell, a miracle of manufacturing, was made with precision, each shell weighing 1,900 pounds of steel casing and 400 pounds of explosive filler, measured to the thousandth of an inch. At the U.S. Naval Gun Factory, each shell was tested by firing it into reinforced concrete blocks, measuring its deflection and cracks. By 1944, the United States was producing tens of thousands of shells, each one identical, each lethal, each a mathematical promise. The difference between Japan and the United States was now clear. While Japan could produce 1 battleship every 2 years, America was launching 4. While Japan still relied on optical gunnery, the U.S. had integrated radar into over 60 major warships. And while Japan's shipyards struggled with fuel shortages, America's yards operated 24/7, powered by floodlights that made night indistinguishable from day. Admiral Raymond Spruance described the Iowa as a weapon that speaks the language of industry. When the Iowa fired, it wasn't just an attack, it was a statement of power. Each salvo represented thousands of workers, engineers, and factories working in unison. The Japanese intelligence reports before the Lady Gulf operation spoke of Americans escorting their carriers with fast battleships, something they thought impossible. But to the Americans, speed was the new armor. A warship that could strike and vanish before counterfire arrived was invincible, not by superstition, but by physics. In Tokyo, Admiral Toyota Suimu still believed in a single decisive battle that could turn the war in Japan's favor. But the Iowa class was built to make that idea obsolete. These ships didn't wait for a decisive battle. They created it at will, from any distance, at any hour. The Iowa's superiority was not just in its weapons, but in the mathematics and physics that governed every aspect of its design. When steel spoke louder than strategy, honor, bravery, and fate gave way to cold, relentless industrial firepower. And on that October night, the men of the Iowa proved that no amount of courage could outrun a 2,700-pound shell traveling faster than sound. As the crew aboard the Kumano argued, another shell slammed into the forward deck, collapsing it like paper. Within moments, communication lines went dead. The bridge lost contact with the engine room, and flooding spread through the lower compartments. Crews worked frantically to seal the bulkheads, but the pressure from each blast distorted the steel doors. The ship's damage control officer ordered counter-flooding to stabilize the list, but the pumps were inoperative. By 07:10, the Kumano was barely moving. Meanwhile, on the Iowa, data poured into the fire control computer. Spotter planes above relayed adjustments, 50 yards short, shift 2 to ground north. The next salvo landed perfectly. Through the haze, the gunners saw the Kumano's bow lift from the water, smoke boiling from its midsection. The Mark 38 director tracked the stricken cruiser with cold efficiency. Each adjustment led to another burst of flame, another piece of steel twisted beyond recognition. For the Americans, it was execution by geometry. For the Japanese, it was horror and revelation. They had once believed that armor could protect them, that battles were decided by courage and proximity. Now, from 35 kilometers away, a single American ship was rewriting all the rules they had followed. The ocean between them no longer offered safety. It was merely empty space, waiting to be filled with fire. When the firing stopped, the Iowa's deck was coated with soot and shell residue. The gun barrels glowed dull red from the heat, and the air smelled of ozone and burned metal. Below, the analog computers hummed softly, their gears still spinning, ready for the next target. The crew moved methodically, resetting, cleaning, preparing. No cheers, no celebration, just discipline. They knew the math had spoken, and its verdict was final. By 07:20, radio intercepts confirmed that a Japanese cruiser, engulfed in flames and listing heavily, was abandoning ship. The radar operators noted the fading echoes as scattered debris. 6 shells, that was all it took. 6 shells that traveled more than 20 miles, guided not by eyesight or luck, but by machine certainty. Far to the west, survivors from the Kumano floated amid the wreckage, stunned and silent. Some whispered prayers to the Emperor, while others simply stared at the rising sun, reflected in the oil-slicked waves. They hadn't even seen their enemy. The attack had come from beyond their sight, beyond their understanding. In that moment, Japan's Navy realized what it meant to face a nation that had turned science itself into a weapon. By mid-morning, the Philippine Sea had become a graveyard of smoke and drifting debris. The Japanese center force was in retreat, scattered and broken after the battle off Samar. But its surviving ships were about to face an even more devastating blow. Not from aircraft or torpedoes, but from the stark realization that the ocean no longer protected them. Aboard the Kumano, the deck was slick with burning oil. The forward turret had been sheared off, its gun barrels uselessly pointed at the sky. Survivors clung to the twisted railings, coughing through thick smoke. The ship's list had increased to 20 degrees, and the engineering officer, Lieutenant Yoshida, tried to restart the pumps manually. His face was blackened with soot, but every command line, wire, and pump shaft had been bent or severed by the force of the Iowa's shells. He later recalled, "It felt as though the sea itself had turned against us. There was nowhere to run." Across the radio network, confusion spread. The nearby Suzuya cruiser reported multiple heavy-caliber impacts from an unknown origin. Destroyers Noaki and Shimakaze sent fragmented coordinates before losing contact. Japanese signal operators believed they were being jammed by American aircraft. They couldn't fathom that the noise flooding their receivers was shock interference from radar-guided naval gunfire. By noon, Tokyo headquarters received garbled reports. Some suggested air attack, others claimed submarine torpedoes. No one could believe that a single battleship could deliver that kind of destruction from over 20 miles away. Admiral Toyota demanded confirmation. Vice Admiral Kurita's response, frail and static-filled, was brief. Enemy guns too far to see, too accurate to fight. That line, too accurate to fight, spread through Japan's Navy like an infection. For decades, their doctrine had been built on decisive battles between fleets facing each other at close range, gunners guided by optics and captains maneuvering by intuition. But the Iowa had fired from beyond the horizon, guided not by men's eyes, but by machines. Every principle Japan's Navy had trained for was suddenly obsolete. The survivors aboard the Kumano watched their ship slowly die. At 0:05, a secondary explosion erupted in the aft magazine, sending steel fragments across the deck like shrapnel from a giant grenade. The hull groaned, twisting under its own weight. The captain, realizing the ship was unsalvageable, gave the order, "Abandon ship." The words came too late for many. As lifeboats hit the water, another shell struck near the bow, throwing a column of spray and flame into the air. Moments later, the Kumano rolled to starboard and slipped beneath the waves, leaving behind a burning field of oil-slicked debris and men struggling against the waves. Miles away, aboard the Iowa, the bridge crew watched through binoculars as the distant smoke faded from view. The radar display confirmed the cruiser's final echo as it dissipated into the sea. As the Kumano's crew argued, another shell struck forward of the bridge, collapsing the deck like paper. Communication lines were severed instantly, and the bridge lost contact with the engine room. Flooding quickly spread through the lower compartments, and men scrambled to seal the bulkheads. The force of each explosion had warped the steel doors, rendering them ineffective. The ship's damage control officer ordered counter-flooding to stabilize the list, but the pumps were non-functional. By 07:10, the Kumano was drifting, barely moving. On the Iowa, the fire control system was hard at work, processing incoming data. Spotter planes above relayed adjustments, 50 yards short, shift 2° north. The next salvo landed perfectly. Through the smoke, the gunners saw the Kumano's bow lifting from the water, smoke billowing from its midsection. The Mark 38 director locked onto the target with mechanical precision. Each adjustment meant another burst of flame, another piece of steel twisted beyond recognition. For the Americans, it was a calculated execution. For the Japanese, it was a horrifying revelation. They had once believed that armor could protect them, that battles were decided by courage and proximity. Now, from 35 kilometers away, a single American ship was rewriting every rule they had ever followed. The ocean between them offered no safety. It was simply empty space, waiting to be filled with fire. When the firing ceased, the Iowa's deck was covered with soot and shell residue. The gun barrels glowed dull red from the heat, and the air was thick with the smell of ozone and burned metal. Down below, the analog computers hummed softly, still spinning, ready for the next target. The crew moved with practiced precision, resetting, cleaning, preparing. No cheers, no celebration, only methodical discipline. They knew the math had spoken, and its verdict was absolute. By 07:20, reports came through radio intercepts, confirming that a Japanese cruiser, ablaze and listing heavily, was abandoning ship. The radar operators confirmed the echo, fading into scattered debris. 6 shells, that was all it took. 6 shells that traveled more than 20 miles, guided not by sight or luck, but by machine precision. Far to the west, survivors from the Kumano floated among the wreckage, stunned and silent. Some whispered prayers to the emperor, while others simply stared at the rising sun reflected in the oil-slicked waves. They had never even seen their enemy. The attack had come from beyond their sight, beyond their comprehension. In that moment, Japan's navy realized what it meant to face a nation that had turned science itself into a weapon. By mid-morning, the Philippine Sea had become a graveyard of smoke and floating debris. The Japanese center force was in retreat, scattered and broken after the battle off Samar. But its surviving ships were about to face an even more devastating blow, not from aircraft or torpedoes, but from the realization that the ocean no longer protected them. Aboard the Kumano, the deck was slick with burning oil. The forward turret had been sheared off, its gun barrels pointed uselessly toward the sky. Survivors clung to the twisted railings, coughing through thick smoke. The ship's list had increased to 20°. Lieutenant Yoshida, the engineering officer, tried to restart the pumps manually, his face blackened with soot. But every command line, every wire, every pump shaft had been bent or severed by the force of the Iowa's shells. He later recalled, "It felt like the sea itself had turned against us." There was nowhere to run. Across the radio network, confusion spread. The nearby Suzuya cruiser reported multiple heavy-caliber impacts from an unknown source. Destroyers Nowaki and Shimakaze sent fragmented coordinates before losing contact. Japanese signal operators thought they were being jammed by American aircraft, unable to believe that the noise flooding their receivers was shock interference from radar-guided naval gunfire. By noon, Tokyo headquarters received garbled reports. Some suggested air attacks, others claimed submarine torpedoes. No one could fathom that a single battleship could cause such destruction from over 20 miles away. Admiral Toyota demanded confirmation. Vice Admiral Kurita's response, weary and crackling with static, was brief. Enemy guns too far to see, too accurate to fight. That phrase, too accurate to fight, spread quickly through Japan's navy like a contagious fear. For decades, their doctrine had been built on battles between fleets facing each other, gunners guided by optics and captains maneuvering by intuition. But the Iowa had fired from beyond the horizon, guided not by men's eyes, but by machines. Every principle the Japanese Navy had relied on was now obsolete. The survivors aboard the Kumano watched their ship slowly succumb to the damage. At 08:05, a secondary explosion erupted in the aft magazine, sending steel fragments across the deck like shrapnel. The hull groaned, twisting under its own weight. The captain, realizing the ship was beyond saving, gave the order, "Abandon ship." The words came too late for many. As lifeboats hit the water, another shell struck near the bow, throwing a column of spray and flame into the air. Moments later, the Kumano rolled to starboard and slipped beneath the waves, leaving a field of burning oil and wreckage. On the Iowa, miles away, the bridge crew watched through binoculars as the smoke faded from view. The radar display confirmed the cruiser's final echo, dissolving into the sea. The survivors from Kumano were rescued days later by destroyers that still reeked of fuel and smoke. One petty officer noted in his journal, "We fought as warriors. They fought as engineers. We could not match them because we could not build them." The equation of the Pacific War was simple. As the machinery grew stronger, the individual grew smaller. A gunner's precision mattered less than the accuracy of a lathe. Back in Illinois, a captain's bravery was insignificant against radar-guided shells. In this new type of warfare, emotions were replaced by precision. Still, amidst the mechanical perfection, human traces remained. In the mess hall that evening, sailors sipped black coffee and ate stale bread, quietly discussing home. Someone mentioned the guns had fired fewer shells than expected. Another claimed to have seen something burning far off, but wasn't sure if it was a ship or an oil slick. No one spoke of death. They simply nodded, finished their coffee, and returned to their stations. That night, as the Iowa moved eastward, Inen Kent stood alone on deck, watching the moon's reflection dance over the black water. He thought about the men on the other side, those who never saw the shells coming. "Maybe they thought they were safe because they couldn't see us," he wrote. "We thought we were right because we could." He didn't know then, but historians would later mark that night as the turning point in modern naval warfare, the moment when human instinct finally yielded to industrial precision. From that point, victory was no longer about bravery, but efficiency. In the following weeks, silence engulfed the Imperial Navy like a shroud. Official reports claimed Kumano's loss was due to an aerial attack, avoiding any mention of radar-guided gunfire. Within Tokyo's naval ministry, the truth was only whispered behind closed doors. The reports that reached Admiral Toyota were clinical and devastating. 6 shells, all hits, all fired from beyond visual range. The Admiral read the words twice before setting the page down. "We were not defeated by courage," he said softly. "We were defeated by calculation." For decades, Japan's military doctrine centered on Kantai-Essen, the decisive battle. Admirals believed that with discipline, willpower, and tactical brilliance, a smaller fleet could destroy a larger one. This belief had shaped every ship built, every sailor trained. But the Iowa's salvo proved that decisive battles no longer required proximity or bravery. They required production lines, factories, and algorithms. The age of the warrior was replaced by the age of the machine. The intelligence division compiled sparse data. Survivor accounts described explosions that came without warning, impacts that ignored armor angles, and shock waves so intense they warped bulkheads before detonation. Analysts compared shell fragments. Each bore identical machining marks, evidence that the Americans were producing weapons with industrial precision, not artisanal variants. Every shell, one report noted bitterly, is perfect. That word haunted Japan's engineers. Perfection required repetition, and repetition required power, fuel, steel, and labor, resources Japan no longer had. Their shipyards were operating at a fraction of capacity. Blackouts crippled production. Bombing raids had destroyed aluminum plants. Even if Japan could design a countermeasure, they could never mass-produce it fast enough. For every Japanese shell, the Americans produced 50. The psychological toll was deeper than any physical loss. Naval officers who once recited Bushido now spoke of mathematics with fear. To face the Americans was to face inevitability itself, a process so vast and efficient that individual bravery was meaningless. One officer reportedly said, "We trained men to fight. They trained machines to think. How do you fight a nation that no longer depends on men?" Across the Pacific, American analysts studying intercepted Japanese traffic noted the change in tone. Radio messages became shorter, less confident, more mechanical. The flowery phrases of imperial pride vanished, replaced by cold coordinates and evacuation orders. Admiral Nimitz, reading these reports, understood what it meant. The enemy had realized that the war was no longer a duel of fleets, but a collision of economies. Back in the United States, newspapers celebrated victories at Leyte Gulf and the destruction of Japan's surface fleet. Few readers understood what had truly happened that night. They saw headlines about heroic gunnery and unmatched marksmanship, not the reality that machines were now making decisions faster than men could act. To the American public, it was proof of their nation's might. To Japan's admirals, it was the end of an era. Admiral Toyota ordered the surviving officers of the Center Force to Tokyo for debriefing. In the meeting, he asked a simple question.
"Why did our armor fail?"
The room fell silent until an older engineer spoke up. "It did not fail, Admiral. It was simply irrelevant." Outside Japan's naval headquarters, winter winds howled through the city. The same winds carried the scent of burning fuel from nearby shipyards struck by American bombers. The empire that had once dreamed of dominating the Pacific now faced the cold calculus of defeat. Courage could not outpace production. Faith could not deflect radar. The ocean, once their sanctuary, had become the world's largest firing range. On the Iowa, life moved on. The guns were cleaned, the radar recalibrated, and the ship refueled, reassigned to bombard coastal targets. For her crew, the 6 shells fired that morning were already history. For Japan, they were prophecy. In that brief exchange of fire, Japan had glimpsed its future, a world where technology erased distance and machines determined outcomes long before men could act. When the war ended, less than a year later, Japan's naval archives were opened to Allied investigators. Among the documents was a handwritten note, believed to be Toyota's final wartime reflection. It read, "We built ships for heroes. They built systems. The heroes died. The systems endured." In retrospect, historians would mark the Iowa's salvo as the moment the industrial age reached its peak. It wasn't just the destruction of a ship. It was the death of an idea that wars could still be won by valor. After that day, steel and circuitry replaced myth and glory. The sea no longer favored the brave. It favored the efficient. As the echoes of those 6 shells faded into the deep, they carried with them the end of an empire and the birth of a new world. A world where machines spoke louder than men. If you've watched until now, consider this: how much of history was truly shaped by courage and how much by calculation. Comment 1 if you believe industrial power decides wars, like if you still believe human will can change destiny. And don't forget to subscribe for the next story of how machines, not men, changed the fate of nations.